This program, DFTCONV, demonstrates circular convolution. The top two panels show sequences x of n and h of n. You specify these sequences with these two boxes here and here. For example, 131 and 111. The length of both of the sequences, n, is shown in this box here. The allowed values of n are limited to even numbers up to 16. If a sequence is specified with fewer than n digits, zeros will be appended to the end. If a sequence is specified with more than n digits, the sequence will be truncated back to n digits. You can also adjust the values of the sequences by dragging sequence elements up or down. The white portions of the display show the actual sequences x of n and h of n, and the shaded portions on either side show the periodic extension of these sequences. You can also shift either of the sequences circularly modulo n by dragging in the appropriate display. Now consider determining the value of the circular convolution of x of n and h of n at a single value of n. Say n is equal to 0. First, flip h of n to form h of minus k modulo n. The two panels now show x of k and h of minus k modulo n. The third panel shows the product of these two sequences, and the fourth panel shows the sum of the product, which is y of 0, in this case 1 times 1 is 1. The red marker here or here shows the value of n at which the convolution is being computed. To find the next value, y of 1, shift h of minus k to the right to form h of 1 minus k modulo n. To shift, either use the slider or enter a value in the edit box, or shift directly by dragging in one of the panels. By flipping x instead of h, you can demonstrate the commutative property of circular convolution. Finally, you can demonstrate that time domain aliasing occurs when the length of x plus the length of h exceeds the length of the DFT, which is n. For example, in this case, we will get time domain aliasing, and circular convolution will no longer be equal to linear convolution. We can show the linear convolution by checking this box here. The linear convolution is in red, the circular convolution is in blue. This program is one of a suite of programs that I have developed to explain DSP concepts to my students during lectures. There are now well over 24 programs covering many aspects of the material in the book, including complex exponentials and sinusoids, convolution, the DTFT, pole zero plots and their relation to frequency and impulse response, A to D and D to A conversion, including upsampling, downsampling, resampling, and aliasing, the design of many types of FIR filters and their application to the filtering of speech and other signals, the design of IIR filters, circular shift and convolution using the DFT, the discrete cosine transform, and the short-time Fourier transform. A selection of these programs is being made available to instructors who are currently adopting the book in their classrooms. For further information, please visit cambridge.org/Holton.